Welcome back, everybody. We are continuing with 12.1, but today we're looking at what we call the inverse trig functions. We'll see how this relates to what we did yesterday. Now, so far we have typically used sine, cosine, and tangent to find missing side lengths of a triangle. Okay, in fact, let's write that out. So we used sine, I'm writing out the whole word here, cosine, and tangent to find missing sides. Of a triangle. Okay. Today we're going to learn how to find missing angle measures, and that's where these trig functions that come in that are called the inverse trig functions. So we will use inverse sine, inverse cosine, and inverse tangent to find missing angles. Of a triangle. If I could pick one thing for you to remember from today, it's this. When you're looking for sides, you use plain old sine, cosine, and tangent. When you're looking for angles, you're going to eventually, we'll see how we actually set this up, but you'll be using inverse sine, cosine, and tangent. Now, you may have seen these buttons in the calculator already. They look like this. It looks like sine, like to the -1 power. It's unfortunately we don't have a different notation, but that's not what it means. That is inverse sine. It has nothing to do with raising it to the power of -1, if you even know what that does. Okay, so it's inverse sine, inverse cosine of x of some number, and inverse tangent of some number. Okay, now on your calculator, you need to press that second button first, second key, and then hit sine, cosine, or tangent. You should see them there. Of course, let me know if you're having trouble finding it on your calculator. Now, here's what they are. Okay, we're going to talk about kind of the definition of them first, and I think conceptually this is a little bit challenging, so feel free to pause and rewind and watch this a couple times until you kind of grasp what's going on here. The actual calculations I don't think are that difficult, but the conceptual understanding takes some time to get there for this to really click. Okay, so here's what this means. Let's say if sine of theta, so this is from yesterday, equals some number x. If it helps to think of that x as a fraction, great. Okay, so if the opposite over hypotenuse of some angle is some number x, then theta is equal to the inverse sine of x. See how things kind of flip-flopped there? They sort of switched places. Okay, so if sine of some angle is equal to x, then that angle is equal to the inverse sine of the ratio. All right, let's use a specific example. I think this is helpful. So let's say maybe not if, but if sine of 30 degrees, if you remember this from yesterday, that's 1/2. So for every 30-degree angle in a triangle, the opposite over hypotenuse always reduces to 1/2. Okay, so we know that. So if sine of 30 is equal to 1/2, then, I'm going to write this slightly differently than above, inverse sine of 1/2 must equal 30 degrees. Okay, so here's what this is really going on here. If you were, and you can go ahead and try this, check your mode, make sure you're in degree mode, but if you were to put this in the calculator, you're basically telling the calculator to find the angle. So as soon as you hit the inverse button, we know we're looking for an angle. Find the angle whose sine or whose opposite over hypotenuse would be 1/2. And the only time that happens is with a 30-degree angle. Okay, so let's write this out. So you're telling the calculator to find the angle, theta, whose sine or opposite over hypotenuse is 1/2, or reduces down to 1/2. Okay, that's what that is finding for you. All right, go back if you need to rewind and watch that little bit. I think that's not a bad idea until you kind of grasp what's going on here. And it may take some time. It might take going through some practice problems as well. Okay, so the first example we're going to look at is just a straight calculation. We're not even going to have a triangle yet. So let's look at part A here. We are given that cosine of some angle is equal to 0.707. We're going to find what angle that might be. Okay, so we're basically trying to find, let me write this out. We want to find the angle whose cosine is adjacent over hypotenuse, so whose adjacent over hypotenuse is equal to 0.707. Right, that's what we're trying to figure out. Now, to actually do this calculation, we're really just trying to get theta all by itself here. What we are not doing, let me repeat, what we are not doing is, don't write this on your paper, we are not dividing by cosine. We're not dividing by cosine because we weren't initially multiplying by cosine. Remember, this is not, do not put a multiplication symbol in there. That's not what this is. This is not the word cos times an angle. It's cosine of that angle. So to undo the cosine, it's not through division, this is where inverse cosine comes into play. So what we're going to do is to take the inverse cosine, and just like any other equation, what you do to one side, you have to do to both. So take the inverse cosine of both sides. Now watch how I'm writing this. There is a particular way you need to write this out. So I'm going to take inverse cosine of all of this stuff. The parentheses means substitution, not multiplication in this case. I'm going to take inverse cosine on my left-hand side, and then I'm going to take inverse cosine of my right-hand side. Because it's substitution, you have to plug these things into inverse cosine. You have to write inverse cosine before all the other stuff, right? Inverse cosine, then all the other stuff. So that inverse cosine should sort of come first. Now, here's why we do this. These cancel each other out. So we're left with theta all by itself. Okay, and theta is equal to inverse cosine of 0.707. That can go right in the calculator. And again, you're telling the calculator to find the angle whose cosine is about 0.7, or find the angle that would have an adjacent over hypotenuse. When that reduces down or you divide that, it's about 0.7. Should be getting about 45 degrees. If you're not, make sure you hit inverse cosine, so second cosine, and make sure you're in degree mode. Let's try one more like that. Example B. We are given that tangent of theta is equal to exactly the square root of 3. Let's find theta. Okay, so let's just think about solving for theta. We don't divide by tangent. We take the inverse tangent of both sides. That's what's going to cancel out the tangent. Okay, so we're also going to take inverse tangent of the square root of 3. Now on the left, goodbye, goodbye, those cancel out. Theta is equal to the inverse tangent of the square root of 3. Okay, so let me pause right here and kind of talk about what that means again. We're telling the calculator to find the angle whose tangent is opposite over adjacent. So find the angle whose opposite over adjacent is equal to the square root of 3. Put it over 1 if that helps. I think it's helpful in this case to think of that as a fraction. Now in the calculator, you're just going to plug this in. You should notice that you actually get exactly 60 degrees. Hopefully these numbers are looking somewhat familiar. Let's think about the special right triangle that has these numbers in there. All right, so if you think about 30, 60, 90, and I'm kind of noticing, okay, I've got a 1 and a square root of 3. I know those are sides of this triangle. 1 is the short leg, 2 is the hypotenuse, square root of 3 is the long leg. So it's saying find the angle that has an opposite as a square root of 3, an adjacent side of 1. Okay, so opposite square root of 3 is 60, and then yes, adjacent to that. Right, so this is the opposite, this is the adjacent. We're talking about a 60-degree angle. Okay, so that's if you have just plain old equation, that's how you solve for theta. You use those inverse trig functions to undo sine, cosine, or tangent. Now let's work with a angle. And this is going to start out very similar to what we did yesterday. Okay, so let's draw, oh boy, the right triangle. And let's label our angles A, B, and C. And then I'm going to put 8 for the length of side CB and 15 for the length of side AB. And we are going to find the measure of angle A. That's our goal. Now this is going to start out in a very similar way that the problems did yesterday. We're going to start by labeling our triangle first. Now in this case, though, we're missing the angle. So our little stick figure person is just going to go in the angle that we're looking for. So I'm going to put my little person here. And then based on where we're standing, let's label the two sides that we have. Okay, so this is the opposite. This is the adjacent compared to this little guy here. Now, just to note, you'll see some problems where they actually give you all three sides. Just pick 2 of them. We never want to label all 3 because then SOHCAHTOA is not helpful. So if you think about SOHCAHTOA, that says, okay, we're going to use tangent because we've got an opposite and adjacent. And I'm actually going to start writing down the exact same equation that we did yesterday. Do not use the inverse right off the bat. We're still going to start here. Okay, we're still going to plug in everything we have, but here's the difference. We don't know theta this time. We're just going to call that A. We do know both of the sides. Okay, now we're going to solve for A. So we do that by taking the inverse tangent of both sides. On the left side, these cancel out. A is equal to, sorry about that, inverse tangent of 8/15. Now remember what we're telling the calculator. We're saying, okay, we know we have this triangle where the opposite and adjacent are 8/15. Can you tell me what the angle looks like? We plug that in. It's about 28 degrees. Okay, the only angle out there that could kind of have these particular side lengths, this particular ratio of side lengths is a 28-degree angle.